While many of the topics I speak on are applicable to large areas, today I'm going to focus on my home state of Maryland. If you're a Marylander and you've looked at your electric bill lately, you've probably noticed that electricity costs in this state are rising much faster than the national average. While there are several factors involved, one reality is becoming increasingly difficult to ignore. Maryland's energy policies have contributed to a growing supply shortage. So for years, Maryland has pursued aggressive climate and clean energy goals. Part of that strategy involved retiring coal-fired power plants and discouraging investment in traditional fossil fuel generation. The intention was to reduce greenhouse gas emissions and accelerate the transition to renewable energy sources. But while generation was being retired, replacement capacity wasn't always being built quickly enough to maintain a comfortable margin of reliability. Today, Maryland is a net importer of power. Buying power from neighboring states is expensive. So today, the regional grid operator is warning about tightening reserve margins as electricity demand continues to grow. Data centers, electrification, population growth, and economic development are all increasing the need for reliable power. At the same time, many dispatchable generating units, plants that can produce electricity whenever it's needed, regardless of whether the wind is blowing or the sun is shining, those have been taken offline. Having worked in the environmental and air quality field for more than 35 years, I've watched that proverbial pendulum swing back and forth when it comes to utilities. When I started my career, coal-fired power plants were a dominant part of the electric grid. Then we saw a major shift away from coal due to environmental regulations and market forces. Natural gas emerged as the preferred replacement because it provided reliable power with significantly lower emissions. But in recent years, even some natural gas projects faced opposition as states pushed toward increasingly ambitious decarbonization goals. Now, we're seeing the pendulum swing once again. As concerns about grid reliability and rising electric rates grow, policymakers and utilities are once again discussing the need for additional dispatchable generation. In many cases, that means new natural gas-fired power plants or expansions of existing facilities. The conversation has shifted from simply reducing fossil fuel use to balancing three competing objectives: reliability, affordability, and environmental performance. For those of us in the air quality field, this trend has important implications. Any new fossil fuel generating facility will require extensive air permitting. Before a project can move forward, developers must demonstrate compliance with federal and state air quality regulations. That means conducting detailed air dispersion modeling analyses to evaluate impacts on national ambient air quality standards, PSD increments, air toxics, and other regulatory requirements. So whether it's a new natural gas combined cycle facility, peaking unit, or an expansion of an existing plant, air quality modeling will be a critical part of the permitting process. As Maryland and the broader Mid-Atlantic work to address growing electricity demand, I expect we'll see increased interest in projects that require sophisticated air quality analyses and regulatory support.